Hi everyone, back again with another video. I am Dinuth. Thank you so much for tuning in. Today is the second video in the Certified Kubernetes Application Developer Refresher video series. I have made my first video on CKAD core concepts that will be covering the API primitives, config, namespaces, as well as how to configure the basic pods. In that video, I have given around 80 plus must know commands. So if you haven't watched that video, I'll include the link in the description and up here. Please go and then watch that video. And today is the second video in this series that is covering the configuration domain number 2, that will give 18% weightage during the exam. Under the configuration domain, you need to understand the ConfigMaps, security context, and define applications resource requirements, and create and consume secrets, and understanding the service accounts. So let's refresh your knowledge in these subdomains during this video. Let's get it started. Config maps are used to store application environment specific configurations as key value pairs. These key value pairs can be passed into the application when you are creating the container as environment variables or configuration arguments, or as the configuration files itself. This allows you to decouple application environment specific configurations from your Docker images and makes your application portable. You can deploy it into any of the environment by simply changing the values in your config maps. Imperative way to create the config map is using kubectl create config map command. You can type kubectl create config map. Config map short form is CM. Instead of using config map, you can use CM as well. Afterwards, you can provide the config map name. Then you can provide all the key value pairs with -- from literal parameter. If you already have these parameters in a property file will look like this. It will have all the key value pairs. You can pass this property file directly into this kubectl create config map command using -- from file parameter. If your property file includes comments like this, rather than using -- from file, you can use -- from env file. In that case, all of these comments will be ignored and it will pick up all of these key value pairs correctly and then loaded into the config map that you are creating. When you want to load an entire file as the value for a key, you can use -- file and provide the key and equals the file name afterwards. When you create the config map with this notation, it will look like this. You can see entire content that you have in the file will be loaded into the key name that you have provided in the command. Rather than creating the config map, if you want to export it as a YAML file and then save it into a file, you can use try run client and -o YAML and then save it into the file. In that case, the file would look like this. And after that, if you want to edit it, you can do the editing. You can apply the changes using kubectl create -f, provide the file name, or else if you want to change an existing config map with the YAML file, you can use kubectl apply -f and the file name as well. You can get the list of config maps using kubectl get config maps command. If you want to edit a config map, you can use kubectl edit config map and then provide the config map name. If you want to describe an config map, you can use kubectl describe config map and the config map name. Mounting the config map into the pod containers can be done in 3 ways. First option is using the env from. You can add this notation inside the container of the pod. env from, and afterwards you can provide the config map details using config map ref, and you can provide the name of the config map. In that case, all the key value pairs that you have in this config map will be added into the container as environment variables. Environment name would be the key and the value of that environment variable would be the value. Rather than mounting the entire config map as the environment variables, if you want to mount specific keys into the container using a different environment variable, you can use env section. Under the env section, you can provide the name and provide the environment variable name. If you want to hard code the environment variable value, provide the value directly. If you want to pull the value from a config map, you can use value from, and under that you can provide config map key ref and provide the name of the config map and the key. The next option is mounting the configuration into the container as files. The file names would be the key names that you have provided in the config map, and the content of that file will be the value that you have provided for each key. To make this configuration, under the pod spec section, you will be adding a volume, and you can provide a volume name, and afterwards you can provide the config map section and then provide the name of the config map. Then you need to go into the container definition inside the pod and add the volume mounts and provide the what is the mount path as well as what is the volume name that you have provided in the volume configuration. If you have not yet subscribed into my channel, please do hit on the subscribe button with the bell sign to get notified when I upload a new video. Next section under configuration is secrets. Secrets are same like the config maps. The only difference is config maps are used to store the application configurations, and if there are any sensitive information, rather than using config maps, you will be using secrets for that. For an example, if you have any passwords, tokens, SSH keys, in that case you will be putting those configurations into secrets rather than using config maps. There are three types of secrets that you can configure: generic, Docker registry, and TLS. Generic secrets are used to store the username, passwords, tokens, kind of information. To create a generic secret, you can use kubectl create secret generic, then you can provide the secret name. Same like the config maps, afterwards you can use from literal and provide the key value pairs in plain text. And if you want to pull the secrets from a property file, you can use the from file parameters as well. You can export this secret configuration as YAML using --dry run client -o YAML and then save it into a file. When you edit this file, you can see that the values that you have provided has been converted into base 64. When you want to edit this secret manually in the file, you need to make sure the values that you are putting are base 64 encoded. If you want to encode a value into base 64, you can use terminal commands itself. You can echo the value without the new line using echo -n and the value. Then with a pipe, you can pass it into base 64. That will encode the value that you have provided. You can copy that value, go into that file and then update it. And then from the value to create the secret, you can use kubectl create -f or kubectl apply -f commands. In the same way, if you need to decode a base 64 value, you can use the same echo -n and the base 64 value. You can pass it into base 64 with the -d flag that will do the decoding rather than doing the encoding. You can get the secrets using kubectl get secrets command. You can describe the secrets using kubectl describe secret command, and then you can edit the secrets using kubectl edit secrets command. Same like the config map, there are three ways to mount these secrets into the containers in a pod. You can use env from parameter and provide the secret ref with the secret name. In that case, all the keys that you have inside the secret will be the environment name, and the value will be the plain text value of the secret. If you want to mount an specific key of the secret with a different environment name, you can use the env section and provide the what is your env name. You will be picking up the value from secret key ref, and you will be providing the name of the secret and the secret key. Third option is mounting the secret as files. You can configure the volume in the pod spec section. You can provide the volume name and secret and provide the secret name. To mount the volume into the container, under the container configuration section, you can add the volume mounts, and you can provide into which folder, which path you need to mount the secret, and within that folder path it will create multiple files with the key name, and the content will be the values that you have provided within the secret in plain text. The next type of secret is Docker registry. You can store your Docker registry credentials in a secret. To create this secret, you can use kubectl create secret. The type will be Docker registry. You can use your arbitrary name for the secret. Then afterwards, you can provide what is your Docker server, what is your Docker username, password and the email address. After creating this secret, to ask a pod to use this particular secret to pull the images, you can use image pull secrets and then provide what is my secret name. In that case, to pull the Docker image, it will be using this secret to authenticate with your Docker registry. Next secret type is TLS. You can use this to store your certificate and the certificate keys inside the Kubernetes secret. To create this, you can use kubectl create secret. The type will be TLS and the secret name --cert and the certificate path --key and the key file path. Then it will create the secret. Kubernetes security context defines the privileges and access control settings for your pods and the containers. This includes setting up the user ID, the group ID, running the pods in the privileged or unprivileged modes, setting up different Linux capabilities and more. Security context can be configured in the pod level as well as in the container level. If it is configured in the pod level, that will be applicable into all the containers within the pod, and if it is configured within a container, this will be applicable for that particular container. If it is configured in both the places, pod level security context definition will have the highest precedence. This is an example where security contexts are configured in the pod level as well as in the container level. You can use run as user, run as group, fs group, and then set the group and the user ID is there. To set the root file system as read-only, you can use read-only root file system. To allow the privilege escalation, you can use allow privilege escalation option. Even you can override these parameters for a specific container under the container security context section. Additionally, need to mention that the Linux capabilities can only be set in the container level. You cannot set it in the pod level. You can find out these Linux container capability details in the documentation as well. You need to know how to configure the resource requirements for the pods such as CPU and the memory. This configuration has two levels. Number one is how much resources this container is requesting. That will be used by the pod scheduler to identify the correct node to place this pod, and the pod can utilize more than the requested resources. How much maximum of resources that it can utilize will be configured with the limits configuration. When you are configuring the CPU, this is equivalent to 1 hyperthread, or else if you are using AWS, it will be equivalent to 1 CPU. If you are in GCP, that will be equivalent to 1 core, and if you are in Azure, that will be equivalent to 1 Azure core. When you configure the CPU as 0.1, that is equivalent to 100 M, and the minimum value for the CPU is 1 M. When you are configuring the memory, if the unit is not defined, that means you are configuring it with the byte level. You can use KI, MI, GI to represent the kilobyte, megabyte, gigabyte in the binary scale. If you want to configure it in the decimal scale, you can use KMG to represent kilobyte, megabyte, and gigabyte. When you are creating a pod with kubectl run command, you can pass this request CPU and the memory requirements using --request parameter. Then you can provide how much CPU and how much memory with comma separated. You can pass the limits using --limits and the CPU and the memory requirement. This is how it will look like in the YAML definition. You can see under the containers, there will be resources section. Then you will have the limits, CPU, memory, and the request CPU and memory. When the pod tries to utilize more CPU than the limits, the Kubernetes will throttle the CPU, and when the pod tries to utilize more memory than the defined limit, the pod will get terminated with the status OOM killed. If you want to define default CPU and memory request and limit values for a namespace, you can use limit range configurations for that. This is how the limit range definition would look like. Inside that, you will be defining what is the namespace. Default request section will be used to define the resource request requirements. Default section will be used to define the limits. Resource quotas can be created for a namespace to limit how much pods can be configured within that namespace, and then altogether how much resources that it can utilize, how much resources that it can request using the pods and then request CPU, request memory, limit CPU, and limits memory. You can use kubectl commands to create this resource quota. You can use kubectl create quota and then provide a name. Then afterwards you can use -- hard, then provide what are my resource requirement limitations inside that. Service accounts are links to authentication, authorization, and the RBAC in the Kubernetes cluster. User accounts are used by the humans, but when you want to assign permissions into machines or else some application to perform some task within the Kubernetes cluster, you will be using service accounts. As an example, if you have Jenkins set up in your Kubernetes cluster for the continuous integration, after building your application, if the Jenkins wants to deploy your application automatically into the Kubernetes cluster, Jenkins should have the permission to deploy pods into the Kubernetes cluster. That permissions can be granted by creating a service account and then creating the role bindings into this service account. To create a service account, you can use kubectl create service account and provide the service account name. You can get the service account list using kubectl get service account. Kubectl describe service account and the service account name will show the details about the service account. When a service account is created, Kubernetes will automatically create a secret with the tokens, and then this token can be used to authenticate with the Kubernetes API. These secret details can be seen in the describe command output. When you describe that secret, you can find out the certificate and the token value as well. This token can be used as a bearer token to authenticate with the Kubernetes APIs like you see in the screen right now. To assign a service account into a pod, you can use service account name parameter under the pod's spec section like you see in the screen. To assign the permissions into the service account, you need to create roles and role bindings, but RBAC configurations are out of scope for the certified Kubernetes application developer certification. Now we have reached the end of this video. During this video, we have covered the configuration domain that covers ConfigMaps, secrets, security context, resource requirements, and the service accounts. I hope you refresh your knowledge in these domains during this video. Thank you so much for coming this far. Please do hit on the subscribe button and the bell sign to get notified when I upload my new video on the other domains in the CKAD exam. As well as I'm making a lot of videos on Kubernetes as well as other cloud services, different cool tips and tricks. So definitely it will be worth to subscribe into my channel. Thank you so much. Let's meet in a new video. Until that, bye bye.